6.1 day 2, we're looking at the law of sines, and we're going to look at the areas of oblique triangles, and then we're going to use the law of sines to model and solve real life problems. So area of an oblique triangle, so we remember that the height equals the base, b times sine of A. So area equals 1/2 of the base times the height, which is 1/2, and in this case, C, times the height, and remember the height is this, so C times B sine of A. And then we can simplify that a little bit more, so the area equals 1/2 BC sine of A. So area of an oblique triangle, the area of any triangle is 1/2 the product of the lengths of two sides times the sine of their included angle. So it could be area equals 1/2 B times C sine of A, or 1/2 A times B sine of C, or that equals 1/2 A times C times sine of B. So one thing to note, just as an FYI, is that when an angle, and let's just start with angle A, is 90 degrees, this formula, the area gives a area of a right triangle. So for example, let's do area equals 1/2 BC, and we'll say sine of 90 degrees. So remember that sine of 90 degrees, what is that? That is just 1. So 1/2 of BC times 1. And then remember what BC is from the top. B is our base, or that B is this value here, and then C is the height. So that's why we know, this is the formula we really remember. It's 1/2 of base times height. And that's when one of the angles is 90 degrees, right? So this is the case where an A is 90 degrees. We get 1/2 base times height. And then it's also true if C equals 90 degrees and then B equals to 90 degrees, we would get the same thing. We're working with oblique triangles though, so find the area of a triangular lot. Find the area of a triangular lot with two sides of lengths 90 meters and 52 meters and an included angle of 102 degrees. So this is side angle side, SAS. So side with an included angle and the side. So we're trying to find the area. So remember the area, and we're going to use 1/2, and we're given A and B. So A times B times sine of C. So we just plug it in. 1/2 of 90 times 52 times sine of 102 degrees. So you plug it into the calculator. Now what I do, just for me, is that I just take half of 90, so 90 divided by 2 is 45. Then I multiply 45 times 52 times the sine of 102 degrees. Now when you do that, your final answer will be 2,289 square meters. So try this example. Find the area of a triangle lot with two sides of lengths 24 meters, 18 meters, and an included angle of 80 degrees. So you don't necessarily need to know all of the letters for that. So I know that the two side lengths are 24 and 18, and then the angle is 80 degrees, included angle. So I just did 1/2 times 24 times 18 times sine of 80 degrees, and that is approximately 213 meters squared. So let's try an application of the law of sines. The course for a boat race starts at point A and proceeds in the direction south 52 degrees to point B. Okay, so it starts at point A in the direction 52 degrees south here to point B in the direction south 40 degrees east to point C, and finally back to point A. Point C lies 8 kilometers directly south of point A. So it's helpful. It has nice diagrams for us to help us out. We need to approximate the total distance of the race course. So the total distance, we're looking for the perimeter, so we need to find out all the sides of this triangle. So one thing that we know is that we have these lines here. And what we know about these lines is that they are parallel. Okay, so knowing that they are parallel, it'll really help us out in finding out other angles. So remember, if these are parallel lines cut by a transversal, then that tells us that this angle here, the alternate interior angle, is also 40 degrees. Then knowing that that is 40 degrees, we can figure out this angle here. So that angle will be 180 degrees minus 52 degrees minus 40 degrees. So that gives us 88 degrees for angle B. So this is 88 degrees. So now we need to find C and A here. So we can use A over sine of A equals, we know, B over sine of B. So we're solving for A. So A equals sine of A times B over sine of B. So this is sine of 52 degrees times 8 over sine of 88 degrees. And so we find that that is 6.31 kilometers is A. Then we need to find the other length, C. So C over sine of C equals B over sine of B. So C equals sine of C times B over sine of B. So this is sine of 40 degrees times B, which is 8, over sine of 88 degrees. And so that is approximately 5.15 kilometers. So now to find the total distance, you add it all together. The distance is going to be 8 plus 6.31 plus 5.15, and so the distance is approximately 19.46 kilometers. And so now I want you to try this example down here. On a small lake, you swim from point A to point B at a bearing of north 28 degrees, then to point C at a bearing of north 58 degrees west, and finally back to point A as shown in the figure. Point C lies 800 meters directly north of point A. We need to approximate the total distance that you swim. All right, if you tried this out, you would find, first of all, that C over here is going to be 58 degrees, right? So alternate interior angles are congruent, so that's 58 degrees. Therefore, angle B is 94 degrees. Then you find side A and side C. So you do A equals sine A times B over sine of B. That is approximately 376.49 meters for A. Then C equals sine of C times B over sine of B, and you would get 680.10 meters. Then you add it all together to get the total distance, which is 1,856.59 meters.